session, we will discuss the shape of the covalent compound using the valence shell electron pair repulsion theory. We will discuss the shape of molecules and ions using the valence shell electron pair repulsion theory. This theory is based on the repulsion between the valence shell electrons, as the name suggests. According to this theory, the shape of molecule depend upon the number of electrons pairs present around the central atom. Now electron repel each other as the like charges repel each other. So the shape of molecule would be stable if the electrons are maximum distance apart. If the electrons are maximum distance apart, then there is the maximum stability. Now the electron pairs around the central atom tend to occupy the position where there is minimum repulsion between the valence shell electrons. For example, if we take the case of the beryllium chloride, in beryllium chloride, the two electron pairs are maximum distance apart, and that is possible only if they are at 180 degree to each other. That is, they are having the linear geometry. Now all the repulsion between the valence shell electrons are not same. Like around the central atom, there are lone pair repulsion is there, lone pair bond pair repulsion is there, and bond pair. Because lone pair are present on a one atom, so it is loosely held. Therefore lone pair repulsion around the central atom is maximum. Whereas bond pair is the present between two atoms, it is tightly held. Therefore bond pair repulsion between two atoms is minimum, whereas lone pair repulsion is between the lone pair and bond pair. Now there is a method to determine the valence shell electrons. If we know the valence shell electrons, then we can predict the shape of the molecules. This method is known as the Axc method. And what does A stands? A means that is it is a central atom, whereas X means that the total number of atoms surrounding the central atoms. E refers to the lone pair present on the central atom. Now if we calculate the total electron pairs present in the valence shell of the central atom, which we are representing as A, then this number is known as the steric number. In steric number, total number of atoms bonded to central atom plus total number of lone pairs. If there is no lone pair around the central atom, then E is considered as 0. To take an example of water, oxygen is having 6 electrons in its valence shell. 2 electron it has given to the 2H atom for the sharing. Now it is having 4 non-bonding electrons, means it is having 2 lone pair. Thus it means what is the steric number of the water? So in place of X, we will place the 2 H atoms are bonded to the oxygen, which we can see from this structure itself. And to find out the lone pair, we have drawn this Lewis dot structure, in which we can find out that there are 2 lone pairs are present on the oxygen atom. Therefore steric number for the water is 4. Now if we know the steric number, then according to the valence shell electron pair repulsion theory, the shape of molecule is possible, that is, in which there is a minimum repulsion between the valence shell electron. Now how these 4 electrons would be arranged in which there is a minimum repulsion? That is tetrahedrally, which we will discuss later on. Take an example of beryllium chloride. In beryllium chloride, firstly we will calculate the steric number. In steric number, we will place X and E, where X represents the number of atoms bonded to the beryllium, which we can see from this. There are 2 Cl atoms are bonded to beryllium. Then it means in place of X, we will place value 2. Now around beryllium atom, beryllium is having 2 electrons in its valence shell. So from Lewis dot structure, beryllium has no lone pair. So in place of E, we have written the 0. Thus, the steric number for beryllium chloride is 2. The shape would be linear, in which there is a minimum repulsion between the valence shell electron. The bond angle between these two bond pair is 180 degree, and it is known as the linear geometry. Now we take a next example, BF3. So firstly we will calculate the steric number. In steric number, again we take X plus E. X is the number of atoms bonded to central atom. So there are 3 fluorine atoms are bonded to the boron atom. Now we know from its Lewis dot structure that boron is having 3 electrons in its valence shell, and it has given its 3 electrons to these 3 fluorine atoms for sharing. So now boron is having no lone pair in the valence shell. So in place of E, we have placed 0 value. So steric number come out to be 3. Now when the steric number is 3, then shape would be trigonal planar. In this way there is a minimum repulsion between these electron pair and they are 120 degree apart. The bond angle between these atoms is 120 degree.